Chemical properties of sulfur, preparation methods, and applications. Sulfur is a nonmetallic chemical element with the symbol S and atomic number 16. It is a pale yellow, odorless, and brittle solid at room temperature. Sulfur is known for its distinctive smell when burned, and its compounds are widely used in many industries. In this article, we will discuss the chemical properties of sulfur, its preparation methods, and its applications. Chemical properties of sulfur. Sulfur is a highly reactive element and forms many compounds with other elements. Some of the important chemical properties of sulfur are: 1. Sulfur has 6 valence electrons and can form 2 covalent bonds with other elements. 2. Sulfur can also form ionic bonds with metals, such as in the compound sodium sulfide, Na2S. 3. Sulfur reacts with oxygen to form sulfur dioxide, SO2, and sulfur trioxide, SO3, which are important industrial chemicals. 4. Sulfur can also react with halogens to form sulfur halides, such as sulfur hexafluoride, SF6. Preparation methods of sulfur. Sulfur is found in nature in its elemental form, and it can also be obtained from sulfide minerals. However, the most common method of preparing sulfur is by the Claus process, which involves the reaction of hydrogen sulfide, H2S, with sulfur dioxide, SO2, to produce elemental sulfur. Another method of preparing sulfur is by the Frasch process, which involves the use of superheated water to melt sulfur underground and bring it to the surface. Applications of sulfur. Sulfur has many important applications in various industries. Some of the major applications of sulfur are: 1. Sulfur is used in the production of sulfuric acid, which is one of the most widely used industrial chemicals. 2. Sulfur is used as a fungicide and pesticide in agriculture. 3. Sulfur is used in the vulcanization of rubber, which gives it improved strength and elasticity. 4. Sulfur is used in the production of black gunpowder, which is used in fireworks and explosives. 5. Sulfur is also used in the production of dyes, detergents, and pharmaceuticals. In conclusion, sulfur is a highly reactive element with many important chemical properties. It can be prepared by various methods, and its applications are wide-ranging in different industries. 6. Sulfur is used in the production of paper, where it is used as a bleaching agent. 7. Sulfur is also used in the petroleum industry to remove impurities from crude oil, and in the production of gasoline and diesel fuels. 8. Sulfur is used in the manufacture of sulfur concrete, which is a durable and chemical-resistant building material. 9. Sulfur is used in the production of batteries, such as lead-acid batteries used in automobiles. 10. Sulfur is also used in the production of cosmetics and skincare products, where it is believed to have therapeutic properties for certain skin conditions. Overall, sulfur is an important element with a wide range of applications in various industries. Its unique chemical properties make it a versatile and valuable component in the production of many essential products. 11. Sulfur is used in the production of fertilizers, where it is an essential component in the form of sulfate. 12. Sulfur is used as a preservative in food and wine production, where it helps to prevent spoilage. 13. Sulfur is used in the production of fire retardants, where it helps to reduce the flammability of materials. 14. Sulfur is used in the production of pharmaceuticals, where it is used as a key ingredient in many medications. 15. Sulfur is used in the production of nylon, where it is used as a precursor in the synthesis of the polymer. 16. Sulfur is also used in the production of matches, where it is used as an igniting agent. 17. Sulfur is used in the construction industry, where it is used to make concrete more durable and resistant to chemicals. 18. Sulfur is used in the production of steel, where it is used to remove impurities and improve the quality of the final product. 19. Sulfur is also used in the production of synthetic fibers, such as polyester and rayon. In summary, sulfur is an essential element in many industrial processes and has a wide range of applications across different fields. Its unique chemical properties make it a valuable resource for many industries, and ongoing research into its properties and applications may uncover new and innovative ways to use this versatile element. 20. Sulfur is used in the production of animal feed, where it is used as a dietary supplement for livestock. 21. Sulfur is used in the treatment of water and wastewater, where it is used as a disinfectant and to remove impurities. 22. Sulfur is used in the production of asphalt and bitumen, where it improves the quality and durability of these materials. 23. Sulfur is used in the manufacturing of detergents and soaps, where it acts as a cleaning agent. 24. Sulfur is used in the production of insecticides and herbicides, where it helps to control pests and weeds. 25. Sulfur is used in the preservation of wood, where it helps to prevent decay and insect damage. 26. Sulfur is used in the production of glass, where it helps to improve the quality and clarity of the final product. 27. Sulfur is used in the production of resins and plastics, where it helps to improve the mechanical properties of these materials. 28. Sulfur is used in the production of ceramics, where it helps to increase the strength and durability of the final product. In conclusion, sulfur is a versatile element with many important applications in various industries. From the production of fertilizers and pharmaceuticals to the preservation of wood and control of pests, sulfur plays a crucial role in the production of many essential products. As such, ongoing research into the properties and applications of sulfur is important for the continued growth and development of these industries. The process of preparing sulfur in English is called preparation of sulfur. Here is a brief description of the process. The main method of preparing sulfur is by mining it from natural sulfur deposits. However, it can also be prepared by the reaction of hydrogen sulfide gas, H2S, with sulfur dioxide gas, SO2, in the presence of a catalyst. This reaction produces elemental sulfur, S, along with water, H2O, as a byproduct. 2H2SG plus SO2G, greater than 3S plus 2H2OG. The sulfur that is produced is usually in the form of a fine powder, which is then purified by sublimation. During sublimation, the sulfur is heated to a temperature above its melting point, but below its boiling point. The resulting vapor is then cooled and condensed, forming pure sulfur crystals. In addition to the above method, sulfur can also be prepared by the Claus process, which involves the reaction of hydrogen sulfide with oxygen to form sulfur dioxide, followed by the reaction of the sulfur dioxide with more hydrogen sulfide to form sulfur. 2H2SG plus 3O2G, greater than 2SO2G plus 2H2OG 2H2SG plus SO2G, greater than 3S plus 2H2OG. The sulfur produced by the Claus process is often used in the production of sulfuric acid. After the sulfur is purified, it can be further processed to produce various sulfur-based compounds, such as sulfuric acid, sulfur dioxide, and sulfates. Sulfuric acid, for example, is one of the most widely used industrial chemicals and is produced by the reaction of sulfur dioxide with water, followed by the addition of more sulfur trioxide. SO2G plus H2OL, greater than H2SO3AC H2SO3AC plus SO3G, greater than H2SO4AC.
Applications of chemistry in medicine. Chemistry plays an essential role in medicine and pharmacy. One application of chemistry in medicine is drug discovery, where chemists design and synthesize new compounds that can be used to treat diseases. Chemistry is also involved in the development of drug delivery systems that can target specific tissues or organs, as well as the formulation of drugs into various dosage forms such as tablets, capsules, and injections. In pharmacy, chemistry is used to analyze and characterize drugs, ensuring their purity and potency. Chemists also develop and test new pharmaceutical formulations to improve drug efficacy and reduce side effects. In addition, chemistry is essential in the understanding of drug interactions, metabolism, and toxicity. Moreover, chemistry is crucial in the development of medical imaging techniques such as magnetic resonance imaging, MRI, computed tomography, CT scan, and positron emission tomography, PET scan. These techniques use chemical compounds to produce images of the inside of the body, allowing doctors to diagnose and treat various diseases. Overall, the applications of chemistry in medicine and pharmacy are diverse and essential for the development of new drugs. Drug delivery systems, and medical imaging techniques, as well as ensuring the safety and efficacy of pharmaceuticals. Chemistry is an important field that plays a critical role in medicine and pharmacy. It has a wide range of applications in these fields, from drug discovery to drug delivery systems and medical imaging techniques. In drug discovery, chemists design and synthesize new compounds that can be used to treat diseases. This process involves the study of the structure and properties of molecules, as well as their interactions with biological systems. Chemistry is also involved in the development of drug delivery systems, which can target specific tissues or organs, and the formulation of drugs into various dosage forms such as tablets, capsules, and injections. In pharmacy, chemistry is used to analyze and characterize drugs, ensuring their purity and potency. Chemists also develop and test new pharmaceutical formulations to improve drug efficacy and reduce side effects. In addition, chemistry is essential in the understanding of drug interactions, metabolism, and toxicity. This knowledge is critical in determining the safety and efficacy of pharmaceuticals. Medical imaging techniques such as magnetic resonance imaging, MRI, computed tomography, CT scan, and positron emission tomography, PET scan rely heavily on chemistry. These techniques use chemical compounds to produce images of the inside of the body, allowing doctors to diagnose and treat various diseases. For example, contrast agents used in MRI are made up of chemical compounds that help to enhance the visibility of certain tissues or organs. In conclusion, chemistry has a significant impact on medicine and pharmacy. Its applications are diverse and essential for the development of new drugs, drug delivery systems, and medical imaging techniques, as well as ensuring the safety and efficacy of pharmaceuticals. The continued advancements in chemistry will undoubtedly lead to new discoveries and innovations in medicine and pharmacy. Chemistry is a field that is essential for medicine and pharmacy. It has many applications in these fields, including drug discovery, drug delivery systems, and medical imaging techniques. In drug discovery, chemists design and synthesize new compounds that can treat diseases. They study the structure and properties of molecules, as well as their interactions with biological systems. In the development of drug delivery systems, chemistry is used to create systems that can target specific tissues or organs. Additionally, chemistry plays a crucial role in the formulation of drugs into various dosage forms such as tablets, capsules, and injections. In pharmacy, chemistry is used to analyze and characterize drugs, ensuring their purity and potency. Chemists also develop and test new pharmaceutical formulations to improve drug efficacy and reduce side effects. The understanding of drug interactions, metabolism, and toxicity is essential in determining the safety and efficacy of pharmaceuticals. Medical imaging techniques such as MRI, CT, and PET scans rely heavily on chemistry. These techniques use chemical compounds to produce images of the inside of the body, allowing doctors to diagnose and treat various diseases. Contrast agents used in MRI, for example, are made up of chemical compounds that help to enhance the visibility of certain tissues or organs. Overall, the applications of chemistry in medicine and pharmacy are diverse and essential for the development of new drugs, drug delivery systems, and medical imaging techniques. The continued advancements in chemistry will undoubtedly lead to new discoveries and innovations in medicine and pharmacy. Chemistry is indispensable in the fields of medicine and pharmacy, and it plays a critical role in drug discovery, drug delivery systems, and medical imaging techniques. Chemists design and synthesize new compounds to treat diseases, and they study the structure and properties of molecules to understand their interactions with biological systems. In the development of drug delivery systems, chemistry is used to create systems that can target specific tissues or organs. And chemistry is also essential in the formulation of drugs into various dosage forms such as tablets, capsules, and injections. In pharmacy, chemistry is used to analyze and characterize drugs, ensuring their purity and potency. Chemists also develop and test new pharmaceutical formulations to improve drug efficacy and reduce side effects. The understanding of drug interactions, metabolism, and toxicity is critical in determining the safety and efficacy of pharmaceuticals. Medical imaging techniques such as MRI, CT, and PET scans rely heavily on chemistry. These techniques use chemical compounds to produce images of the inside of the body, allowing doctors to diagnose and treat various diseases. Contrast agents used in MRI, for example, are made up of chemical compounds that help to enhance the visibility of certain tissues or organs. In conclusion, the applications of chemistry in medicine and pharmacy are diverse and essential for the development of new drugs, drug delivery systems, and medical imaging techniques. The continued advancements in chemistry will undoubtedly lead to new discoveries and innovations in medicine and pharmacy. Chemistry plays an essential role in medicine and pharmacy. It has various applications in these fields, including drug discovery, drug delivery systems, and medical imaging techniques. In drug discovery, chemists design and synthesize new compounds that can treat diseases. They study the structure and properties of molecules, as well as their interactions with biological systems. In the development of drug delivery systems, chemistry is used to create systems that can target specific tissues or organs. And chemistry is also essential in the formulation of drugs into various dosage forms such as tablets, capsules, and injections. In pharmacy, chemistry is used to analyze and characterize drugs, ensuring their purity and potency. Chemistry, understanding the science that shapes our world. Chemistry is a fascinating and complex branch of science that plays a critical role in our everyday lives. From the air we breathe to the food we eat, chemistry is involved in every aspect of our existence. In this article, we will explore the importance of chemistry and how it impacts our world. The basics of chemistry. Chemistry is the study of matter and how it interacts with other matter. Matter is anything that has mass and takes up space. Atoms are the building blocks of matter, and they combine to create molecules, which make up everything around us. The study of chemistry is divided into several subdisciplines, including organic chemistry, inorganic chemistry, physical chemistry, and biochemistry. Organic chemistry focuses on the study of carbon-based compounds, while inorganic chemistry deals with the study of non-carbon-based compounds. Physical chemistry is concerned with the study of the physical properties of matter, while biochemistry is the study of chemical reactions that occur in living organisms. The importance of chemistry in everyday life. Chemistry has a significant impact on our lives, from the food we eat to the medicines we take. One of the most important applications of chemistry is in the production of energy. Fossil fuels, which are used to generate electricity, are made up of carbon-based compounds. Chemistry is also crucial in the development of renewable energy sources such as solar, wind, and hydroelectric power. The food we eat is also a product of chemistry. The science of food chemistry focuses on the study of the chemical processes that occur during cooking and the effects of different ingredients on the taste and texture of food. Food chemistry is also important in the development of new food products and the preservation of existing ones. Medicine is another area where chemistry plays a vital role. The development of new medicines requires an understanding of the chemical processes that occur in the body. Chemists work to create new drugs that can treat diseases and improve quality of life. Chemistry is also involved in the development of medical technologies such as imaging equipment and prosthetics. Current trends in chemistry. Chemistry is a constantly evolving field, and new discoveries are being made every day. One of the most significant trends in chemistry is the development of new materials. Chemists are working to create materials that are stronger, lighter, and more durable than existing ones. These materials have applications in fields such as construction, transportation, and electronics. Another trend in chemistry is the development of sustainable chemical processes. Chemists are working to create processes that use fewer resources, generate less waste, and have a lower impact on the environment. This is crucial in a world where natural resources are becoming increasingly scarce, and pollution is a significant concern. Conclusion. Chemistry is a vital science that impacts every aspect of our lives. From the food we eat to the energy we use, chemistry plays a critical role in shaping our world. As we continue to face new challenges, such as climate change and resource depletion, the importance of chemistry will only continue to grow. By embracing sustainable practices and developing new materials and technologies, chemists can help create a better, more sustainable future for all of us. The importance of chemistry in industry. Chemistry plays a crucial role in various industries, such as agriculture, pharmaceuticals, and manufacturing. In agriculture, chemistry is used to develop fertilizers and pesticides that help increase crop yields and prevent diseases. In pharmaceuticals, chemistry is used to create new drugs that can treat various diseases and illnesses. In manufacturing, chemistry is used to develop new materials and processes that help create better products. One example of the importance of chemistry in industry is the production of plastics. Plastics are used in a wide range of products, from packaging materials to automobile parts. The production of plastics involves several chemical processes, including polymerization and extrusion. Chemists work to create new types of plastics that are more durable and have a lower environmental impact. The future of chemistry. The future of chemistry is exciting, as new discoveries and technologies are being developed all the time. One area of research is nanotechnology, which involves the study of materials at the nanoscale level. Nanotechnology has the potential to revolutionize various industries, from medicine to electronics. Another area of research is artificial intelligence, AI, and machine learning. Chemists are using AI and machine learning to analyze large amounts of data and develop new materials and processes. This approach has already led to significant breakthroughs in drug development and materials science. How to learn chemistry. Learning chemistry can be challenging, but it is also rewarding. There are many resources available for those who want to learn more about chemistry, including textbooks, online courses, and videos. One of the best ways to learn chemistry is to take a course at a college or university. This will provide you with a solid foundation in the subject and allow you to interact with other students and professors. Another way to learn chemistry is through online courses or videos. There are many free resources available online, such as Khan Academy and MIT OpenCourseWare. These resources provide lectures and tutorials on various topics in chemistry and allow you to learn at your own pace. Conclusion. Chemistry is a vital science that impacts every aspect of our lives, from the food we eat to the products we use. It plays a critical role in industry, medicine, and the environment. As we continue to face new challenges, such as climate change and resource depletion, the importance of chemistry will only continue to grow. By learning about chemistry and supporting sustainable practices, we can help create a better, more sustainable future for ourselves and future generations. Chemistry knowledge, applications, and importance in modern life. Chemistry is a fundamental branch of science that deals with the study of matter, its properties, and interactions. It is a broad field that covers various areas such as organic chemistry, inorganic chemistry, physical chemistry, and biochemistry. Chemistry plays a critical role in our daily lives, from the food we eat to the products we use. In this article, we will explore the importance of chemistry knowledge and how it impacts modern life. Linus Pauling, 1901 to 1994, was an American chemist and peace activist who made groundbreaking contributions to the fields of chemistry, biochemistry, and molecular biology. He was born in Portland, Oregon, and grew up in a family that valued education and science. Pauling received his undergraduate degree in chemical engineering from Oregon State University and his Ph.D. in physical chemistry from the California Institute of Technology. In the early years of his career, Pauling focused on the study of chemical bonds and developed the concept of electronegativity, which describes the ability of an atom to attract electrons. His work in this area led to the development of a theory of chemical bonding that has been widely adopted in the field. During World War II, Pauling turned his attention to the study of proteins and developed an understanding of their structures and functions. He also worked on the Manhattan Project, which developed the first atomic bomb, but later became a vocal opponent of nuclear weapons and a leading figure in the movement for nuclear disarmament. In 1951, Pauling published a paper on the structure of DNA in which he proposed a three-stranded model that was later disproven. However, his work paved the way for the discovery of the double helix structure of DNA by James Watson and Francis Crick. Throughout his career, Pauling received numerous awards and honors, including 2 Nobel Prizes. He won the Nobel Prize in Chemistry in 1954 for his work on chemical bonds and the nature of the chemical bond. In 1962, he received the Nobel Peace Prize for his activism in opposing nuclear weapons and promoting disarmament. Pauling was also an outspoken advocate for the use of vitamins and other nutritional supplements to maintain health and prevent disease. He wrote numerous books on the subject and founded the Linus Pauling Institute at Oregon State University to continue research in this area. Pauling's legacy continues to inspire scientists, peace activists, and advocates for health and wellness around the world. In addition to his work in science and peace activism, Pauling was also involved in politics and social justice causes. He was an early supporter of the civil rights movement and spoke out against segregation and discrimination. During the McCarthy era of the 1950s, Pauling was targeted by the government for his political views and activism. He was accused of being a communist sympathizer and was subjected to harassment and persecution by the authorities. Despite these challenges, Pauling continued to speak out on issues of importance to him, including nuclear disarmament, environmental protection, and human rights. He remained a leading figure in the scientific community and continued to publish research throughout his life. Pauling passed away in 1994 at the age of 93. He is remembered as a brilliant scientist, a tireless advocate for peace, and a champion of social justice and human rights. His contributions to science and society continue to be celebrated and studied today. Throughout his career, Pauling published over 1,200 scientific papers and authored or co-authored more than a dozen books. In addition to his 2 Nobel Prizes, he received numerous other awards and honors, including the National Medal of Science, the Lomonosov Gold Medal, and the Presidential Medal of Freedom. Pauling was also a prolific public speaker and lecturer, traveling extensively to share his ideas and insights with audiences around the world. He was known for his ability to explain complex scientific concepts in terms that were accessible to the general public, and he was a popular figure in both scientific and non-scientific circles. In recognition of his contributions to science and society, many institutions have been named. In Pauling's honor, including the Linus Pauling Science Center at Oregon State University and the Linus Pauling Middle School in Corvallis, Oregon. Overall, Linus Pauling's life and work represent a remarkable legacy of scientific achievement, social activism, and humanitarianism. His contributions continue to inspire and influence people in fields ranging from chemistry and physics to medicine, politics, and social justice. One of the most significant contributions made by Linus Pauling was his work on the nature of the chemical bond. His pioneering research in this area helped to establish the modern understanding of chemical bonding and provided the basis for the development of new materials and technologies. Pauling's work on the structure of proteins and other molecules also had a major impact on the field of molecular biology. His discoveries helped to establish the fundamental principles of molecular structure and function, paving the way for advances in fields such as drug discovery and biotechnology. In addition to his scientific work, Pauling was also an influential figure in the peace movement. He was a vocal opponent of nuclear weapons and worked tirelessly to promote disarmament and international cooperation. His efforts helped to shape the debate around nuclear policy and contributed to the eventual reduction of nuclear arms during the Cold War era. Throughout his life, Pauling remained committed to promoting public understanding of science and its role in society. He believed that science had the potential to address many of the world's most pressing problems, from disease and hunger to environmental degradation and social inequality. Today, Linus Pauling's legacy continues to inspire scientists, activists, and humanitarians around the world. His contributions to science and society have had a lasting impact, and his dedication to the pursuit of knowledge and the promotion of peace and justice remains an example for us all to follow. Linus Pauling was also a strong advocate for the use of high-dose vitamin C in the prevention and treatment of various illnesses, including cancer and the common cold. Although his views on this subject were controversial at the time, subsequent research has shown that vitamin C can play an important role in maintaining health and preventing disease. Pauling founded the Linus Pauling Institute at Oregon State University in 1973 to advance research on the health benefits of vitamins and other nutrients. Today, the institute continues to conduct cutting-edge research in this area, with a focus on understanding the mechanisms by which these substances can promote health and prevent disease. Despite his many achievements, Linus Pauling was not without his critics. Some of his views on science and medicine were considered unorthodox, and he was often accused of being overly dogmatic in his beliefs. Nevertheless, his contributions to science, peace, and humanitarianism remain an inspiration to millions of people around the world. In recognition of his many accomplishments, Linus Pauling was awarded numerous honors and accolades during his lifetime, including 2 Nobel Prizes, the National Medal of Science, and the Presidential Medal of Freedom. He was also inducted into the National Inventors Hall of Fame and the California Hall of Fame, among other honors. Overall, Linus Pauling was a remarkable individual who made significant contributions to science, peace, and social justice. His legacy continues to inspire and influence people around the world, and his commitment to advancing knowledge and promoting human. Linus Pauling's contributions to science and society have been recognized not only through awards and honors, but also through numerous institutions and programs that bear his name. In addition to the Linus Pauling Institute at Oregon State University, there is also the Linus Pauling Medal, which is awarded by the American Chemical Society to recognize outstanding contributions to chemistry. There are also several buildings and facilities named after Pauling, including the Linus Pauling Science Center at Oregon State University and the Linus Pauling Middle School in Corvallis, Oregon.
Chemistry is a branch of science that deals with the study of matter and the interactions between different substances. It is an essential science that plays a significant role in our daily lives. In fact, chemistry has impacted almost every aspect of our daily lives, from the food we eat to the clothes we wear, the medicines we take, the cosmetics we use, and the environment we live in. This essay will discuss the influence of chemistry in daily life, exploring some of the most important ways in which it has impacted our lives. One of the most significant impacts of chemistry in daily life is in the food we eat. Chemistry is involved in every step of the food chain, from the production of fertilizers to the processing of food, packaging, and preservation. Fertilizers are essential for the growth of plants and crops, and they are made of a variety of chemicals, such as nitrogen, phosphorus, and potassium. These chemicals are crucial in ensuring that crops grow healthy and yield abundant harvests. Additionally, chemistry is also involved in food processing, such as baking, cooking, and freezing. It is also essential in preserving food, as certain chemicals can be added to food to prolong their shelf life. For example, preservatives such as sodium benzoate, sodium nitrite, and potassium sorbate are commonly used in foods such as canned goods, pickles, and jams to prevent spoilage. Chemistry also plays an important role in the clothes we wear. The fibers used to make clothes are often made of synthetic materials such as polyester, nylon, and spandex. These synthetic materials are created through chemical reactions and processes, and they have transformed the fashion industry. They are durable, comfortable, and easy to care for, making them an attractive alternative to traditional fabrics. Additionally, dyes and pigments used in the production of clothes are also made through chemical reactions. They are used to add color and patterns to clothes, and they have enabled the production of a vast array of clothing styles and designs. Medicine is another area where chemistry has had a significant impact on daily life. Chemists have played a crucial role in the development of new drugs and treatments for a variety of diseases and conditions. Through the use of chemical compounds, researchers have been able to develop drugs that can target specific cells and molecules in the body, enabling more effective treatment of diseases. Additionally, chemistry is also involved in the development of medical equipment, such as imaging devices and surgical tools. These devices are often made of materials such as titanium, which is biocompatible and does not react with the body's tissues. Cosmetics and personal care products are another area where chemistry has had a significant impact. The ingredients used in these products are often derived from chemical compounds, such as surfactants, emulsifiers, and preservatives. These ingredients are essential for creating products that are effective, safe, and aesthetically appealing. For example, surfactants are used in shampoos and body washes to create a lather that helps to remove dirt and oil from the skin and hair. Emulsifiers are used to create smooth and stable creams and lotions, while preservatives are used to prevent the growth of bacteria and fungi in these products. Chemistry has also had a significant impact on the environment we live in. Chemists have developed new technologies and processes that can help to reduce pollution and improve the quality of the air, water, and soil. For example, catalytic converters are used in cars to convert harmful pollutants such as carbon monoxide and nitrogen oxides into less harmful gases. Additionally, chemistry is also involved in the development of renewable energy sources such as solar and wind power. Chemists are developing new materials and processes that can make these technologies more efficient and cost-effective. helping to reduce our dependence on fossil fuels. Another important area where chemistry has had an impact on daily life is in the field of electronics. Electronic devices such as smartphones, computers, and televisions are made of materials such as silicon, copper, and gold, all of which are products of chemical processes. The microchips that power these devices are also created through a series of chemical reactions, making chemistry essential in the development and production of these devices. Additionally, batteries used in electronic devices are also made of chemical compounds, such as lithium-ion batteries. Chemistry is also important in the field of agriculture. Pesticides and herbicides are commonly used to protect crops from pests and weeds, and these chemicals are created through a series of chemical reactions. However, the use of these chemicals has raised concerns about their impact on the environment and human health. To address these concerns, chemists are developing new, safer alternatives to traditional pesticides and herbicides, such as biopesticides and natural weed control methods. Water treatment is another area where chemistry has had a significant impact on daily life. Water treatment plants use a variety of chemical processes to remove contaminants from water and make it safe for human consumption. Chemicals such as chlorine and ozone are commonly used to disinfect water and kill harmful bacteria and viruses. Additionally, chemicals such as alum and iron sulfate are used to remove impurities and particles from the water. Finally, chemistry has had an impact on the field of sports and recreation. Sports equipment such as tennis rackets, golf clubs, and running shoes are often made of synthetic materials that are created through chemical reactions. These materials are designed to be lightweight, durable, and flexible, improving the performance of athletes. Additionally, chemicals such as sunscreens and insect repellents are commonly used in outdoor activities, protecting individuals from harmful UV radiation and insect bites. In conclusion, chemistry has had a profound impact on our daily lives, influencing almost every aspect of our lives. From the food we eat to the clothes we wear, the medicines we take, and the environment we live in, chemistry has played an essential role in shaping the world around us. As technology continues to advance, it is likely that chemistry will continue to be a critical discipline in the development of new products and technologies that will improve our daily lives. One area where chemistry is rapidly advancing is in the field of renewable energy. The world is currently facing significant challenges due to climate change and the development of alternative energy sources is a critical step towards reducing carbon emissions and mitigating the effects of climate change. Chemistry plays a crucial role in the development of renewable energy technologies such as solar panels, wind turbines, and hydrogen fuel cells. For example, solar panels generate electricity by converting sunlight into electrical energy through a process called the photovoltaic effect. This process is made possible by the use of semiconductors, which are materials that conduct electricity under certain conditions. The development of high-efficiency, low-cost solar cells has been made possible through advances in chemical synthesis and nanotechnology. Similarly, wind turbines generate electricity by harnessing the kinetic energy of wind. The blades of wind turbines are made of lightweight materials such as carbon fiber, which is created through a series of chemical processes. Sodium is an element that is found in the periodic table with the symbol Na and atomic number 11. This element is a highly reactive metal, which means that it readily reacts with other elements to form compounds. Sodium is one of the most abundant elements on Earth and is widely used in many applications in daily life. This article will explore what sodium element is and its applications in daily life. What is sodium? Sodium is a soft, silvery white metal that is highly reactive and flammable. It is classified as an alkali metal and is part of the first group of the periodic table. Sodium is so reactive that it is never found in its pure form in nature, but rather as a compound with other elements. The most common compound of sodium is sodium chloride, which is also known as table salt. Other sodium compounds include sodium bicarbonate, sodium hydroxide, and sodium carbonate. Properties of sodium. Sodium is a highly reactive metal, which means that it readily reacts with other elements to form compounds. Sodium has a melting point of 97.8 degrees Celsius and a boiling point of 883 degrees Celsius. It is a soft metal that can be easily cut with a knife. Sodium has a density of 0.97 grams per cubic centimeter, which is lower than that of water. It is a good conductor of electricity and heat, and it has a high reactivity with water. Applications of sodium in daily life. 1. Sodium chloride, table salt. Sodium chloride, or table salt, is one of the most widely used compounds of sodium in daily life. Salt is used as a flavoring agent in food and is also used to preserve food. Salt is also used in the production of chemicals, such as chlorine and caustic soda. 2. Sodium bicarbonate, baking soda. Sodium bicarbonate, or baking soda, is another common compound of sodium that is used in daily life. Baking soda is used as a leavening agent in baking and is also used as a cleaning agent. Baking soda is also used in the treatment of heartburn and indigestion. 3. Sodium hydroxide, caustic soda. Sodium hydroxide, or caustic soda, is a strong base that is used in many applications in daily life. Caustic soda is used in the production of paper, textiles, and soap. It is also used in the treatment of wastewater and in the production of aluminum. 4. Sodium carbonate, washing soda. Sodium carbonate, or washing soda, is another important compound of sodium that is used in daily life. Washing soda is used as a cleaning agent and is also used in the production of glass, paper, and soap. 5. Sodium in medicine. Sodium is an essential element for the human body and is required for many physiological functions. Sodium is used in the treatment of low blood pressure and is also used in the treatment of dehydration. 6. Sodium in agriculture. Sodium is used in agriculture as a nutrient for plants. It is also used as a soil conditioner to improve the fertility of the soil. 7. Sodium in water treatment. Sodium is used in the treatment of water to remove impurities and contaminants. Sodium is used in the production of chemicals, such as chlorine, which is used to disinfect water. 8. Sodium in batteries. Sodium is also used in the production of batteries. Sodium batteries have the potential to be a more sustainable and cost-effective alternative to traditional lithium-ion batteries. 9. Sodium in nuclear reactors. Sodium is used as a coolant in some types of nuclear reactors. Sodium-cooled reactors are used in some countries, such as France and Japan. Conclusion. Sodium is an essential element that is widely used in many applications in daily life. From table salt to cleaning agents to battery production, sodium plays an important role in our daily lives. Sodium compounds are used in the production of a variety of chemicals and materials, including paper, textiles, and soap. Sodium is also essential for the human body and is required for many physiological functions. Sodium is used in the treatment of low blood pressure and dehydration, and it is also an important nutrient for plants in agriculture. Properties of sodium. Sodium is a highly reactive metal that is easily oxidized in air. It has a low melting point, 97.8 degrees Celsius, and a low boiling point, 883 degrees Celsius. Sodium is a good conductor of electricity and heat, and it is also a soft metal that can be easily cut with a knife. Sodium is a very reactive element, and it reacts vigorously with water, producing hydrogen gas and sodium hydroxide. 2Na plus 2H2O 2No plus H2. Sodium is also a reactive element that can react with many other substances, such as acids, halogens, and nonmetals. Applications of sodium in daily life. 1. Food. Sodium is a vital nutrient that is required by the human body to regulate blood pressure, maintain fluid balance, and transmit nerve impulses. Sodium is commonly found in many foods, such as table salt, cheese, processed meat, and canned vegetables. However, excessive consumption of sodium can lead to health problems such as high blood pressure, heart disease, and stroke. 2.
Joseph Priestley, 1733 to 1804, was a British polymath who made significant contributions to various fields, including chemistry, physics, theology, and politics. He was born in Fieldhead, England, and was the eldest of 6 children. His father was a cloth dresser, and his mother was a homemaker. Priestley attended local schools and then studied at Daventry Academy, where he was introduced to the works of Isaac Newton, John Locke, and other prominent thinkers. He became a minister in the dissenting church and served congregations in Needham Market and Leeds. Priestley's scientific career began when he became interested in electricity and started conducting experiments to better understand it. He also studied gases and discovered several new ones, including oxygen, carbon monoxide, nitrous oxide, and sulfur dioxide. His experiments on gases led him to develop the theory of phlogiston, which was later disproven by Antoine Lavoisier. Priestley was also an advocate for religious and political freedom. He was a member of the Lunar Society, a group of intellectuals who met regularly to discuss science, philosophy, and politics. He wrote many books on theology and politics, including The History and Present State of Electricity and the Principles of Government. In 1791, Priestley emigrated to the United States due to political persecution in England. He settled in Northumberland, Pennsylvania, where he continued his scientific work and became involved in local politics. He died in 1804 at the age of 70. Joseph Priestley's contributions to science and philosophy had a significant impact on his contemporaries and later generations. He is remembered as a pioneering chemist, a prominent religious figure, and a champion of liberty and democracy. Priestley's discoveries in the field of chemistry were groundbreaking and had a significant impact on the scientific community. His discovery of oxygen was particularly significant, as it fundamentally changed the way scientists thought about combustion and respiration. His work on gases also led to the development of the pneumatic trough, a device used to collect and study gases. In addition to his scientific work, Priestley was a prominent religious figure and an advocate for religious tolerance. He rejected many traditional Christian beliefs and instead believed in the importance of reason and individual freedom. His theological beliefs were influenced by the works of Unitarian thinkers, and he became a prominent figure in the Unitarian movement. Priestley's political beliefs were also shaped by his belief in individual freedom and democracy. He was a strong supporter of the American Revolution and later the French Revolution. He was a member of the Society for Constitutional Information and wrote many political pamphlets, advocating for reforms such as religious tolerance, the abolition of slavery, and the extension of voting rights. Priestley's views on religion and politics made him a controversial figure in his time, and he was frequently the target of criticism and attacks. In 1791, his home and laboratory in Birmingham, England, were attacked and burned by a mob, forcing him to flee to the United States. Despite the controversies surrounding his life and work, Joseph Priestley is widely recognized as one of the most important thinkers of the Enlightenment era. His contributions to science, philosophy, theology, and politics continue to inspire and influence people to this day. Priestley's legacy also includes his influence on other important figures in history. His friend and fellow scientist, Benjamin Franklin, was a close collaborator and corresponded with Priestley for many years. Priestley's ideas also influenced the Unitarian movement in the United States, which was a significant force in American religious and social history. Priestley's work in chemistry had a profound impact on the field, and his discoveries are still studied and applied today. He was one of the first scientists to recognize the importance of experimentation in scientific inquiry, and his methods continue to be used in laboratories around the world. In addition to his scientific and philosophical contributions, Priestley was also an accomplished writer. He wrote more than 150 books and pamphlets during his lifetime, covering topics such as theology, politics, and natural philosophy. His works were widely read and helped to shape the intellectual landscape of his time. In conclusion, Joseph Priestley was a remarkable individual who made significant contributions to multiple fields during his lifetime. His work in chemistry, theology, and politics had a profound impact on his contemporaries and continues to influence people to this day. He was a champion of individual freedom, reason, and democracy, and his legacy serves as an inspiration to generations of thinkers and scholars. Priestley's impact on science extended beyond his own discoveries. He was an influential teacher, and many of his students went on to become important scientists in their own right. He also founded a scientific journal, the Philosophical Transactions of the Royal Society, which became one of the most important scientific journals of its time. Priestley's work on gases and his discovery of oxygen laid the groundwork for future discoveries in the field of chemistry. His experiments also helped to confirm the atomic theory of matter, which became a cornerstone of modern chemistry. In addition to his scientific work, Priestley's contributions to theology and philosophy were also significant. His rejection of traditional Christian beliefs and his emphasis on reason and individual freedom had a profound impact on the development of Unitarianism and other progressive religious movements. Priestley's advocacy for political and social reform also helped to shape the course of history. His support for the American and French revolutions and his work for the abolition of slavery and other social injustices inspired many others to fight for a more just and democratic society. In recognition of his achievements, Priestley was awarded numerous honors and awards during his lifetime, including the Copley Medal from the Royal Society and the Prix Lacaze from the French Academy of Sciences. Today, he is remembered as one of the most important thinkers of the Enlightenment era, and his legacy continues to inspire and influence people around the world. After being forced to flee England, Priestley settled in the United States, where he continued his scientific work and became a prominent figure in American intellectual and political life. He was one of the founders of the American Philosophical Society and served as a professor of natural philosophy at the University of Pennsylvania. Priestley's time in the United States was marked by his continued advocacy for political and social reform. He supported the abolition of slavery and was a strong advocate for religious freedom and tolerance. His outspoken views on these issues made him a controversial figure in the United States, and he was often the target of criticism and attacks. Despite the challenges he faced, Priestley continued to write and publish throughout his life. His last major work, Notes on All the Books of Scripture, was published posthumously and reflects his lifelong interest in theology and biblical scholarship.